Hello there, my name is Kanushri. I am the co host of this meeting. Before we dive into our AP Calculus AB BC Masterclass, I'd like to take a moment to introduce you to the organization making this session possible. Let's Unbound is dedicated to empowering students across more than 25 countries by fostering STEM skills, life skills, and college readiness. Our mission is to help students achieve their life skills by 18 and life goals by 35 through personalized learning and mentorship. With programs ranging from skill development, gifted test, college prep to Ivy League readiness, Let's Unbound has taught over 4,000 students, conducted more than 125,000 hours of teaching, earned a global 4.9 out of 5 rating. By combining innovative teaching methods with strong mentorship, Let's Unbound helps students realize their potential and make a positive impact on the world. So, as we begin today's masterclass, remember you're building skills that will help you excel far beyond the test in college, career, and life. Over to you, Harsh.
Thank you. And like to welcome all of you to this session on AP Calculus AB and BC. Okay, so let's get started. All right. So the AP Calculus AB and the AP Calculus BC focus on the students' understanding of calculus concepts, and they provide the necessary experience with methods and applications. So one thing that we must realize here, the AP curriculum and the AP examination that ways is highly oriented from the applications point of view rather than the theory point of view. Okay, through the big ideas of calculus like modeling, approximation, limiting values, and analyzing different types of functions, each course becomes a cohesive whole rather than a collection of unrelated topics. So if you look at the curriculum of the AP calculus examination, be it AB or be it BC, you would see that it covers almost everything from differential calculus as well as integral calculus. So there is a large amount of syllabus which is covered, which sometimes may appear as if they are non-coherent topics. But overall, if you look at the syllabus from this angle of modeling, particularly, or approximating, limiting value, or function analysis, then it looks like a cohesive whole rather than just a collection of uncorrelated topics. Now, both courses require students to use definitions and theorems to build arguments, justify conclusions. The courses feature a multi-representational approach to calculus with concepts, results, and problems expressed graphically, numerically, analytically, and verbally. So one thing which sets the AP curriculum aside from your normal calculus curriculum would be the usage of graphs. Okay, this curriculum is very heavy on the graphical usage of calculus, and therefore the modeling part or the approximation part, limiting part, etc., the graphs of everything, they are more important compared to just solving numerical problems or analytically solving those questions. Exploring connections among these representation builds understanding of how calculus applies limits to develop important ideas, definition, formulas, and theorem. So overall focus is obviously on the primary concept of calculus. Okay, remember the entire subject of calculus is divided into two parts, the differential calculus and the integral calculus. And that too, we can say there are two major problems that define both these branches. One is the tangent line problem, as we call it, or the limiting value concept, which is the differential calculus part, and another is the area under the curve concept, which is accumulation concept or the integration part. So this curriculum basically unifies both of them together in the form of one is a calculus AB course, the other is calculus BC course. Now AB is designed to be the equivalent of a first semester college calculus course developed to topics in differential and integral calculus. The BC curriculum is designed to be equivalent to both first and second semester college calculus courses. That means overall, we'll come to that part as well. If you look at the credits, the BC most likely will offer twice as many credits as the AB curriculum. Okay, AP Calculus BC applies the content and skills learned in AP Calculus AB to parametrically defined curves, polar curves, and vector valued functions. So there are 2 or 3 additional units, you can say, as far as the BC curriculum is concerned, okay, which takes the discussions that you have in calculus AB forward to concepts like polar curves, vector valued functions, sequences and series, etc. Okay, it develops additional integration techniques, applications, and as I said, the topic of sequences and series. Before studying calculus, what are the prerequisites for these courses? All students should complete the equivalent of 4 years of secondary mathematics designed for college-bound students. Okay, so you must be very comfortable with your uh, algebra concepts, higher algebra, particularly concepts of functions, okay, because they would act as a strong foundation for both AP calculus AB as well as the calculus BC. All types of functions you should have a strong hold. Okay, exponential, logarithmic, trigonometric, piecewise, everything. Basically, the curriculum is about functions. Okay, so without a strong footing in the topic of functions, in overall algebra of functions, graphing, you would not do well with the calculus part as well. So those are the basic prerequisites. Okay. Students must also understand the language of functions, domain range, odd even functions, periodicity, symmetry, zeros, intercepts. Okay. Whether the function is increasing function, decreasing function, etc. Students should know the basic trigonometric know-hows like the sine and cosine functions, tangent function, the value of these functions at different angles like 0, pi by 6, pi by 4, pi by 3, pi by 2, etc. Students who take the AP Calculus BC should have basic familiarity with the concept of sequences and series as well. The concepts of arithmetic progression, geometric progression, all of that would also be required when you go for the Calculus BC part. Okay. Some exposure to parametric and polar equations would also be very handy. So usually we are all familiar with the Cartesian coordinate system, but for the AP Calculus BC part, you must be exposed to the polar coordinate system as well as the parametric coordinate systems. Who should opt for the AP Calculus BC? Now, typically, this is a question a lot of people ask, that should I go for Calculus AB or should I go for the Calculus BC? Okay, so STEM measures, students planning to major in engineering, physics, pure or applied mathematics, computer science, you must go for Calculus BC. Okay, strong math students who have strong aptitude for math, who can handle a fast-paced, more challenging curriculum, should go for Calculus BC. Okay, students who have already done the AP pre-calculus course should also opt for Calculus BC because they already have a strong foundation in the form of the pre-calculus course. You should go for AP Calculus BC. Who should opt for AP Calculus AB? So undecided or humanities major students. Okay, undecided or humanities major, because see, the point we are trying to stress here is if you want to take Calculus BC, okay, there are no half measures then. You have to go all out, and the curriculum is really big when it comes to Calculus BC part. So undecided or humanities measures who do not require maths, physics to a certain extent, they can opt for Calculus AB. Okay, it is still wise to take Calculus AB because in your subject areas also you would require a little exposure to calculus. So it still demonstrates strong math skills without the added rigor of BC. So you don't need to like have a rigorous course like a BC. You can still do with the AP Calculus AB. Students who want more time, because BC requires a lot more time compared to AB, okay, you should opt for AB. Students who are a year or two away from college, who cannot take BC in their senior year, or who feel that it is too rigorous, they can opt for AB and then potentially take BC. If you are comfortable with the AB, you do well on the AB, later on you can decide to take the BC. Okay. Now a comparison between the two. So first point, college credit and placement potential. So I think I've already mentioned that Calculus AB often accounts for credits equivalent to 1 semester of calculus, whereas the BC course can earn you credits for 2 semesters. For example, here you can see at the University of Michigan's engineering program, a score of 5 on the AP Calculus AB earns you 4 credits. Okay, but a score of 5 on the Calculus BC exam earns you 8 credits. So this essentially confirms that BC can give twice the number of credits as AB in lot of cases. Talking about workload and pacing, so obviously the workload of a BC curriculum is definitely higher compared to the AB curriculum. Okay, so you will get less time, obviously, if you are opting for Calculus BC. Also, because of more number of topics to be covered, the pace of Calculus BC is also a little more. It moves faster compared to the AB curriculum. So it can be a little overloading, or it can be a little taxing for you if you are going for Calculus BC. That is why I said no half measures. Once you decide for BC, you have to give everything for the BC part. It will be a little time consuming compared to the AB part. Impact on college applications, especially for competitive schools. If you are targeting schools which are, let's say, tier 1, tier 2 schools, okay, or an engineering program in particular, having a BC or beyond is the norm among the applicants, right? So for example, if you are applying to an MIT for a top engineering course, then you must have good grades on the AP Calculus BC. Okay, that would be much more preferable compared to the AP. Now, talking about the course contents of both the AP Calculus AB and the BC test. So this is what the course content looks like. You can see that there are certain units which belong only to the AB. There are certain units which belong to both AB and BC. Okay. So you can see first unit is that of limits and continuity. So remember, the knowledge of function, that is why I said, is a prerequisite. You will directly start from the concept of limiting value of a function. So when you are starting from the concept of limiting value, they assume that you are familiar with everything related to the concept of functions. You know the domain, you know the range, you know all the different types of functions. You know what is the inverse of a function, odd function, even function. Everything related to function you must know beforehand. You can start with the curriculum of the AP Calculus. So first unit is limits and continuity. Second unit is differentiation. Third unit is the advanced concepts related to differentiation, like the composite function or implicit differentiation, inverse functions, etc. Fourth is the application of derivatives, or you can say the contextual application of derivation. Fifth unit is applying derivatives to analyze functions. So this is more graphical in nature. You can say that. If you look at the percentage weightage, okay, these topics have more weightage on the AB exam rather than the BC exam. BC exam, you can see the weightage is low. Why? Because BC covers more topics compared to the AB course. Okay, so here you can see the first 5 units, definitely more weightage for AB exam, less weightage for BC. Going ahead, unit number 6, integration and accumulation of change, the fundamental concept of integration. Then unit related to differential equation is also there. Then application of integration is also there. Now, this is where the AP Calculus AB syllabus ends. Okay, it ends with this basic concept of application of integration. But beyond this, the BC curriculum continues with advanced topics like parametric equations, polar coordinates, vector valued functions, and the concept of infinite series and sequences. Basically, the convergence and divergence of sequences and series is the major unit. Okay, so you also have the Maclaurin series, the Taylor series, Taylor expansion, etc. So all of that is a part of the BC curriculum only. Other than that, some topics of integration are only covered under the BC curriculum. Also, some topics of differential equations like the logistic model, etc., are covered under the BC curriculum only, not for the AB curriculum. Okay, so if we look at this curriculum from a coverage point of view, typically students, they study differential calculus in their grade 11 and they study integral calculus in their grade 12. So usually it is divided over 2 years of your school studies. But on the AP exam, all of that is combined into one. So it is a lengthy curriculum that ways. And the BC part is typically having those additional topics as well. So it requires a lot of time to cover these topics. It requires a lot of time on your end as well to prepare for these topics. So the AP Calculus exam is for people, as I said, who have to devote more time as far as preparation for this particular exam is concerned. Now, talking about the examination structure, the first section is multiple choice type questions. So you have 30 questions and you are allowed 60 minutes to attempt those 30 questions. Okay. In this particular part, the graphing calculator is not permitted. Then there is part B in the multiple choice section where you have the graphing calculator allowed for this section. You get 45 minutes to answer 15 questions. So that is your section 1, which is MCQ. Then you have the section 2, which is the FRQ or the free response questions. So in the free response questions, again, you have two portions. There is part A where the calculator is allowed or it is required actually. You get 30 minutes to answer just two questions. Okay. And then there is part B in this test where again the graphing calculator is not permitted. You are supposed to answer four questions and you get 1 hour. So all in all, it's a long test. As you can see, the total time required or the total time for this examination sorry, is 3 hours and 15 minutes. Okay. So one of the longest APs you can say is the calculus examination. Now, part of this test, the calculator is allowed. Part of the test, the calculator is not allowed. So you must be aware about the calculator policy completely, and you should know what questions are to be done on the calculator, what questions are to be done without the help of a calculator. So while you are preparing, this knowledge is, I would say, an essential knowledge as far as the calculator usage policy is concerned. Okay, so a four function scientific or graphing calculator is allowed on part B, section 1 and part A, section 2. As I said, it's a longish test. So obviously you also need to develop some stamina to give this particular exam. This is a hybrid digital examination now. Okay, students complete the multiple choice questions and view the free response questions in the Blue Book testing app if you're taking it on the system, obviously. But the responses for the free response questions, the FRQs, have to be handwritten on the booklets provided by the College Board, and then you have to return them for scoring purpose. Okay, this is a sample of that booklet which you get to write your answers for the FRQs or the free response questions. Okay, so you have to write it in the given space as well. You have to follow that space limit and you have to write the answers to all the free response questions in this booklet and submit it. Now, coming to certain sample questions from each of these sections. So we'll just take a quick look at some of the questions here. For example, this is part A. Okay, the graphing calculators are not permitted on this part of the examination. Okay, so we just saw the percentage breakup of the questions in the beginning. So usually these topics would, or these type of questions would appear on both the tests, the AP calculus AB test as well as the AP calculus BC test. But then obviously with AB, you will have more questions from the first 5 or 6 units, whereas in BC, there will be an equal weightage for the later units from 7 to 10 as well. Okay, so let's take a look at some of these questions. So for example, you can see the first question is based on the limiting value of a function. So it says find the limit x tending to 0, 1 minus cos a square 2x divided by 2x whole square. Now, obviously, the question is more oriented to check your trigonometry knowledge as well as the knowledge of the limiting values. So here we can see that 1 minus cos a square 2x is a basic identity which you can write it as sine squared of 2x, and the denominator is also 2x squared. So then you can simply apply the identity that limit x tending to 0 sine theta over theta is equal to 1. Okay, so therefore the answer to the first question is D, 1. Second question you see is based on the concept of continuity of the functions. Okay, so they have given you a piecewise function. It says f of x is 2 over x for x less than -1. F of x is x squared minus 3 for x between -1 and 2 inclusive. And then it is 4x minus 3 for x greater than 2. Okay, so it says that let f be the function defined above. What values of x, if any, f is not differentiable? So this question basically is checking your knowledge about differentiability of the function. Remember, when we say that the left hand limit and right hand limit is equal, the function becomes continuous at a given point. And if the value of function is also equal at that point, then you say that the function becomes differentiable at that particular point. So here, if you will check at different boundary points like -1 and 2, so you will see that at 2, at 2, the function will be not differentiable, as the left hand limit and the right hand limit would not be same. So the limiting value of the function itself would not exist. Therefore, the function won't be differentiable at that point. Okay, then you can see this table above gives the value of differentiable functions f and g and their derivatives at selected values of x. So if h is the function defined by h of x equals f of x times g of x plus 2 times g of x, what would be h prime 1? That means what would be the value of derivative of this function at x equal to 1? So obviously here you see that you have to apply the concept of the product rule as far as the derivatives are concerned. So if you take the derivative of this function, apply the product rule to the first part, and then substitute that value 1, okay, for x, you will actually end up getting the h of x or h prime of x at x equal to 1 equal to 32. So this is about knowing the product rule and then substituting the value of x equal to 1 in the function. Next, you see, you have a question related to implicit differentiation, x cube minus 2xy plus 3y square equal to 7. Okay, you have to find dy over dx. So this is, as I said, a question based on implicit values or implicit differentiation. So you simply differentiate this entire equation with reference to x. So you will get a 3x square, and then for minus 2xy, you apply the product rule. So you will get minus 2 times x plus x times dy by dx plus y times of 1 plus 3y square would be differentiated as 6y dy by dx, and then you just collect the terms of dy by dx, put everything else on the other side. The correct answer will work out to be option B. Fifth question is a basic integration problem. Okay, and you can do it with the help of either trigonometric substitution or simple u substitution as well. You can see that it is integration x over square root of 1 minus 9x square times dx. So in this question, you can simply substitute the 1 minus 9x square as u, take derivative, the x dx would get adjusted as per your derivative. A basic integration question, the final answer should come out to be option A. Similarly, you see, almost every topic gets a representation as far as this first section of the MCQs are concerned. This question, for example, it states that radius of a right circular cylinder is increasing at the rate of 2 units per second. Height of the cylinder is decreasing at the rate of 5 units per second. So which of the following expression gives the rate at which the volume of cylinder is changed? Obviously, they have given you already the relationship between the volume, the radius, and height. It is up to you that you know how to differentiate this equation with reference to time t. Okay, so if you will differentiate this expression with reference to time t, you will get a dv over dt. Okay, dv over dt, and that would be, you can look at it like this, dv over dt would be pi times, which is a constant, and then you take a derivative of r square h. So that would give you r square times dh over dt plus h times 2r dr over dt. So in the problem, they have already given you the value of dh over dt. They have given you the value of dr over dt. You can substitute those two values, the 2 units per second and the 5 units per second there. And if you'll simplify, you will get the answer as 4 pi RH minus 5 pi R square, because you can see the height rate of change is given as a decreasing rate, whereas the radius rate of change is given as an increasing rate. So obviously the dH over dt part, you have to take it with a negative sign. You will end up getting the option as C. Okay, so that is how you deal with the application of derivatives question. Again, the seventh question is a fundamental question as far as the integration topic is concerned. Okay, it refers to your Riemann sums, and you have to just find the interval, the correct interval of the Riemann sum here. So they have said that you have to do it from 2 to 6 integration root x dx. So if you go for 2 to 6, your Riemann integration, the interval comes out to be 6 minus 2 divided by n, which is 4 over n. And then you just apply the basic definition that the Riemann sum is given as limit n tending to infinity, summation of you can say k equal to 1 to or I equal to 1 to k, and f of x, the value of the function, multiplied by delta x, the interval. Okay, so delta x to be taken as 4 over n, the value of function. If you will use that root x, so you will get the 4 over n outside, and then square root of 2 plus 4k over n would be the function inside, or that would be the Riemann sum basically if you go from 1 to n. C would be your correct answer. Again, a very fundamental question based on just the basic definition. Another such application you can see here, it shows the graph of a continuous function g on the interval 0 to 8. Let h be a function defined as hx is integration 3 to x g of t dt. So on what intervals is h increasing? So immediately you apply what is called as the fundamental theorem of calculus. So if you apply the fundamental theorem of calculus, you can, from this relation, you can directly say that because h of x is expressed as an integral of g of t dt, okay, so then you can basically say that your g of x, okay, would simply be your h prime of x, or the first derivative. So whenever you want to find which intervals is the function increasing, the derivatives must be positive. Okay, so we can clearly see here the region between 0 and 1 and the region between 3 and 7 are the regions where the derivative of the function is positive. Therefore, you can say those are the regions where the function original h of x would be an increasing function. Again, a very basic question, very basic concept. Another question, this time it is based on the slope fields as we know them. Okay, this is differential equation. So it says that which of the differential equation is represented by the slope field which is given here. So again, I just look for the horizontal lines, because the horizontal lines would mean that the slope will be 0. So I can see that this is true when y is equal to 2, and this is also true when y is negative 2. So I just look for the option where I should get a dy by dx value equal to 0 if I put y is equal to 2, or if I put y is equal to negative 2. Immediately I know the correct answer is choice B. Okay, so choice B will be the correct answer here based on the basic knowledge that the slope field value, or the slope value basically, is 0 at those values of y. Okay, now these questions are graph intensive, as I said. You can see this particular question, it says R be the region bounded by the graph of x equal to e raised to power y. Now, if somebody has to attempt this question, they must be very familiar with the function x equal to e to the power y. Okay, you can also say that the function x equal to e to the power y will more like, will be expressed as the logarithmic function if you write it as y is equal to fx. So it would look like a logarithmic function, and then you draw the vertical line x equal to 10, the two horizontal lines y is equal to 1 and y is equal to 2. So they are saying that what would be the bounded area in this case. So if you will plot the graphs here, then you will get to know that the area, the function would look something like this. Sorry. And you will have the two horizontal lines. You will have the two horizontal lines like this. Oh, sorry, I think it is malfunctioning a little. Okay. And then you can actually find out the area by subtracting the area of the function from the area of the rectangle that would be formed. So that would give you the integration 1 to 2 10 minus e to the power y dy, option C as your correct answer. Okay. Moving to part B, which is again an MCQ part only, but this time you would need a graphing calculator to solve these type of questions. For example, here it says the graph of function is shown above. What is the limiting value? X tending to 1 plus. So you are interested in knowing the right-handed limit for the function. You can see when you are approaching 1 from the right-hand side, you are actually approaching the value 2. So this one is a straightforward question. The correct answer is C, which is 2. And then it says velocity of the particle moving along a straight line is given as the function 1.3t log of 0.2t plus 0.4 for time t greater than equal to 0. What is the acceleration? So obviously, if the velocity function is known to us, we just need to find the derivative of this function at t equal to 1.2. So if you are using a graphing calculator, you will directly do it on the calculator, and the calculator will directly give you this answer here, which actually would be equal to C, which is negative 0.093. Okay, so direct calculator based questions. Another such question, so they are saying that f be a twice differentiable function, values of f prime, the derivative of f at selected values are given. Which of the following statements must be true? So we can see that overall the f prime values are decreasing continuously, but we are only provided with values at certain values of x. So in between those values, for example, let's say they've given you value at 0, they've given value at 2. It is possible that in between, let's say at 1, okay, the trend might change. So therefore it says f is increasing or it is concave down. We cannot comment. But if we apply the mean value theorem for sure, which is applicable here in the interval negative 1 to 5, we can say that the slope of tangent will become equal to slope of secant. That means the average change will become equal to the instantaneous change at some point. So that some point, if you apply the mean value theorem, that some point would come out to be negative 3 over 2. So the slope of the graph of f dash x would obviously give you f double dash x. So therefore the correct answer here is option D. 14th question, then it says f be function where again you have been given the derivative of the function. It is asking for how many points of inflection. So remember, for points of inflection, your double derivative must be equal to 0. So you simply take the derivative of this function and equate it to 0. So once you take the derivative of this function and equate it to 0, you can do that on the calculator and look for all the points in the interval 0 to 9. Okay, so there will be a total of 4 points. So something which you can do on the graph. Okay. Another question, honey is poured through funnel at the rate of so and so ounces per minute. How many ounces are poured through the funnel for 0 to 3? So we are basically asking for accumulation here, which is directly the definite integral of this function within the limit 0 to 3. Again, you can directly take the help of a calculator, find out integral 0 to 3 of this function. You will directly get your answer as D 7.429. So all these questions, you can directly take the help of a calculator. So the bigger skill, I should say, which is tested here is how comfortable you are using a graphing calculator, which will solve all these questions for you. Then the next part here again is for BC only. This is not for calculus AB, for BC. So obviously here the questions are more related to the BC syllabus. Okay. But again, you have two portions here. In this particular part, the graphing calculator you can see is not allowed. So it says table of values is given. So integration of 2 to 5 f of x dx is also given to you. And they are asking for integration 2 to 5 x times f dash x dx. So this obviously is based on the concept of integration by part. Okay, so there is a direct formula of doing the integration by parts. You can just apply that formula. In that formula, you will require the integral 2 to 5 fx dx, which is given to you as 14. You'll also need the values of fx and f dash x. Those are also given. And then it will simply be a substitution part there. So if you will substitute, the correct answer will come out to be 23. Similarly, more questions, they are checking your knowledge of the BC part. This is a differential equation based on the logistics model or logistics growth model to be precise. So if you know the logistics growth model, this is a direct question that 5,000 in the denominator of f is known as k, the growth factor. So in the limiting case, your value of function is equal to k. Correct answer there will directly be k equal to 5,000, which is option B. So if you know that part directly, very easy question. Again, a parametric differentiation question. They are asking for the second order derivative. So you must know the formula of second order derivative in terms of the first order derivative. You know that, then this is again a very easy question. The correct answer will come out to be option A, which is minus of sine of t squared. Okay. This is based on the convergence of sequences. Again, a standard question which checks your knowledge of the rules applicable for checking the convergence of the sequence. So again, if you know your rules, for example, here, if you know the alternating sequence rule, you know the p test, you will directly come out with your answer, which would be option B. This is again a basic Maclaurin series question. If you know the fundamental series of e raised to power x, you just have to make the substitution of the derivative. So derivative of e raised to power 2x is 2 times of e raised to power 2x. So you can see the last option there is basically substituting 2 times of 2x in the basic e to the power x series. You will get option D as your answer, right? So those are BC specific questions where the calculator was not allowed. This is an example of a BC specific question where calculator is allowed. You can see the equation of the graph is given to us in the form of a polar equation, and they are asking for the area of shaded region. Again, it's a direct formula based question. For polar curves, we find the area as 1/2 times integration theta1 to theta2 times r square d theta. So it's a basic application of integration question. Okay, the polar curve is already given to us 2 plus 4 sine theta. If you equate it to 0, you will get the upper and lower limits of theta1 and theta2. Substitute the value of the curve directly. You can do it on the calculator. You will get your answer as 2.174, which is option A. Okay, again, this is Lagrange's error bound question, which is based on a direct formula. You can do it directly. Okay. Similarly, like the MCQ questions, you have the free response questions as well. Now, preparing for the free response questions is very important. Why? You have to, as I already told you and I showed you that sheet, you have to manually write the answers, and therefore the explanation of the answer is very important. Not writing the correct, I mean, just writing the correct answer is not sufficient. Your explanation of the steps will also be really, really important. So this is where your concepts would be tested a lot. Okay, your conceptual clarity would be checked if you have to answer these questions. For example, here you can see on a certain weekday, the rate at which the vehicle crosses a bridge is modeled by a differentiable function which is given in the interval 0 to 12. Now, R of t is measured in vehicles per hour. T is the number of hours since 7 a.m. Okay, so values of RT for selected values of T are given in the table. So for example, in the first part of the question, they say use the data in the table to approximate R prime of 5. So obviously you apply the basic definition. So that would be R6 minus R4 divided by 6 minus 4. So you take the two neighboring points, you find the slope, that obviously would be R prime value of 5. Okay. B part, it says use a midpoint sum with 3 subintervals and you need to approximate the value of 0 to 12. So basically they have given you the midpoint, they have given you the interval. So you just need to know the formula how to find out using the midpoint, and then you can just put in the values, you will directly get it. Okay. So knowing the formula, writing the formula, putting in the values, finding the answer, all of that has to be a part of your solution that you are going to write as far as the free response questions are concerned as well. Okay. So you have this for BC part as well. So I've already explained you the structure of the test. Approximately 2/3 of the scoring is based on the MCQ and 1/3 of the scoring is based on the FRQ. Now, this is a slightly difficult AP in terms of scoring. So you can expect low scores as far as the grades or low scores corresponding to high grades. So if you have to score a 5 on the AP Calculus BC or the AP Calculus AB test, if you are able to secure, let's say, even a score somewhere around 60, okay, a raw score of somewhere around 60 out of 100, you should be able to score a 5 on this test. Okay, so as I said, it is a relatively difficult scoring exam, that per se. So sometimes even a score of 55 gets you a score of 5 on the AP Calculus BC test. Okay, so somewhere in 55% to 60% range, if you are scoring, most likely you will end up getting a 5. Okay, anything more than 60 is almost a guarantee of a score of 5. Now, coming to the preparation strategies, as I said, one thing about this AP, the curriculum is really lengthy. So you need to create a detailed study plan, set your goals, follow the schedule strictly. Okay, you cannot go away from schedule for this particular AP. Use high quality resources. Obviously, there are official college board materials available. Use reputable prep books. Use practice worksheets. Okay. The key here is important. The important part, as I said, the key here is management of time. Okay. This is a very lengthy test. So sitting for 3 hours and 15 minutes in itself is a challenge. And the curriculum is also, it's like your 11th and 12th combined together, or the entire calculus in one paper. So it's a very longish curriculum that you have to prepare. Okay. Prioritize your active practice. So take full length mock tests, do daily practice. And as I said, prepare separately for the free response questions, because there the answer may not carry, as many marks as the steps. So very important part there would be how you explain your answer. That would be very important. Develop effective test taking strategies. If you are taking the BC, do not forget that there is a lot of stress on BC only topics. Memorize important formulas and theorems. Some of them are there on the formula sheet of the test, but some of them are not there. Okay, your fundamental knowledge of functions would be very, very important. So be very thorough with all of that when you are going for the AP examination. So with that, I'll like to end my presentation there, and I'll keep the forum open for any questions that you have. You may you may feel to ask. Please feel free to ask all your queries. Put them in the chat box if you want to. And if you have questions even after the today's presentation, you may still post them to us. We'll be happy to answer those questions.
Thank you so much for a wonderful session, Harsh. Well, we host unique AP, SAT, and IBDB master classes every weekend, and we'll be sending out email updates to keep you informed. Before we wrap up, I'd also like to take a moment to display our students' AP results. It's truly inspiring to see their hard work and commitment reflected in these scores. That brings us to the close of today's session. I'm going to be sharing some important links in the chat box. Please feel free to save them. Okay. Yeah. So we look forward to welcoming all of you to our upcoming events and masterclasses. Thank you once again for joining us today. Until next time, take care and keep learning.